Hello, mathematicians, puzzlers, and other curious people. Have you ever heard someone say, if this continues, we're going to the dogs? Well, there are different ways that people can talk about the future, and in this video, we are going to look at analyzing some future trends using data and mathematics. So let's take a look. I found some information in a textbook, the details are on your screen, about antidepressant use in the United States among people age 12 and up in two different years, 2009 and 2013. Age 12 and up was probably selected because teenagers and 12-year-olds are physically more similar to adults than they are to little kids, and so they take a lot of the same medications as adults do. So that makes a group that we can use for comparison purposes and do some statistical analysis. We can see that antidepressant use is increasing as a percentage of the population. The absolute change was 2.3 percentage points. This, by the way, is tricky. This shows how even a percent could be an absolute change if it's found by just subtracting to compare. Relative change always has to be considering, even if it's in percentage points, that absolute change as a portion of the original amount. I'm grabbing my calculator and I'm saying, okay, a change of 2.3 percentage points out of an original amount of 10.4 percentage points. So that's about a 22% relative change. And from that, we can extrapolate a growth factor of 122%, which is the same as 1.22. Now that we can see what the trend was between those 2 years, we can do some projections based on that into the future. We can get some ideas of what might happen if this continues. Since we're going to do a lot of repeated calculations as part of projecting this trend out into the future, I'm going to use a spreadsheet because spreadsheets are great at that. Here I have our two data points, the 10.4% antidepressant use in the year 2009 and 12.7% in 2013. I'm going to check something first. I'm going to check what I came up with as the growth factor. I'm going to see if 1.22 times the previous year really does give us, and it does give us the 12.7 that we expect. So from there, we can drag that on down. So according to this, in 2069, more than 200% will use antidepressants. Now, if you're going, wait just a darn second, you're perceptive. There's no such thing as more than 200% of any group having any trait. It's just not possible. So what went wrong here? Clearly we have a case of model breakdown. Sometimes some statistical models work better than others. So one thing we often want to do if we've come up with a prediction that's not believable at all is try to change our model to try to come up with a more credible prediction. What if we also calculate the rate of antidepressant non-use? And from that, we come up with a new model to calculate antidepressant use. Well, you might say, okay, wait, but what's that going to accomplish? Because antidepressant non-use and use are just opposites, so won't that just take it back to where we started? Not necessarily. So we'll start from the same 10.4% we had before. Except we will need to subtract that from 1. And I am not going to take its suggestion about autofilling because I see it's giving me some impossible things. So I see that in 2009, 89.6% of our population were not antidepressant users. In 2013, well, we can drag on down the same formula. We see that that's 87.3%. So now that's decreased by 2.3 percentage points. But what's 2.3 percentage points out of that starting amount? 89.6 percentage points. So we can grab a calculator, negative 2.3 out of 89.6. Okay, so based on these calculations, antidepressant non-use decreases on a relative basis by about 2.5% between those years. As a decay factor, 100%, so 1, minus 2.5%, so 0.025, is a decay factor of 0.975. Well, we can check this. So now we can calculate the previous value times 0.975 and check that. Now, let's see what this comes up with as a new model
for antidepressant use. So if we take 1 minus the antidepressant use, and I'm not going to let it autofill all the way down. Okay, we've got a little rounding error here. So I think I needed to bring along more decimal places here. 2.56666964286. Now, I'm going to bring some more decimal places up here, and I'm just going to stop after 5 decimal places here. So I'll put 0.97433, and now I get what I had before. It's always a good idea at the beginning, if you see what seems to be a rounding error forming, to try to get out ahead of that before you do projections from it, because that rounding error might compound into something important. So now we can drag this on down and see some percentages of antidepressant non-use. And here we can drag on down and see what percentages of antidepressant use we would infer from that. So according to this, in the year 2069, rather than more than 200%, about 40%. It says 39.3%. I'm going to round to the nearest 10% that far out. So about 40% of people in the United States age 12 and up will be antidepressant users. I don't know if that's true, but I think it's a whole lot more plausible than 200%. At least it's a prediction that makes sense and seems possible. So this is a process you can use to look at trends based on data points that you can observe and to project out into the future what might happen, and it might be something that would be important to do for your work. For example, if you were a producer of medications, you might want to make sure that you are planning ahead to be able to have sufficient production capability in case it's true that in 2069, 40% of the population will use antidepressants. And again, that's just one small example. In any field, there could be trends that it would be a good idea to be prepared for. Calculator!